maybe it's
What is
because
that,
it's,
like an OLED or
does it
what's the
need,
display?
does it need to be connected
Hey.
to the internet before it'll do something?
I think.
I think so.
At start, he's trying to connect.
Yeah, I think that's what it's doing.
Let me try this.
The challenge of the library
hotspot.
internet.
Yeah. Library's not working today?
No, the library's fine. It's just other things aren't working.
Okay.
If it's not one thing, it's the other.
That's the way.
That's the general rule, huh?
That's the way it usually works.
So when we did the new one, what's it coming up here?
No, it was last week.
It was last week, okay.
So this is the street price of this is $2.
That's pretty good. Out of how many people? Okay.
You can find them for
So
$2.
respectable showing, better than.
I want to know where my mouse went. There it is.
Oh, is that right?
Seems like
I mean, if you're gonna
$2.90.
go, you might as well. Pretty fierce competition.
$2.50. I don't know what the difference is.
Yeah. You gotta fix
Oh,
it.
$2.90 comes with a nice little case for it. 50 cents would be your nice little case. So the camera is $2.50, and you can save yourself a whole dime if you buy the case and the camera together.
Oh, that's a deal.
How long does it take to get it?
It's China.
2 to 8 weeks. No, I mean, the question is anybody stocking it in the U.S. or?
Oh, probably.
They probably charge you more.
I didn't do an in-depth search. I just
Yeah, I don't
searched
know
for the
for
camera.
$2, I don't know if they'd stock it and ship it from the U.S. Seriously.
They charge you more.
I just did a.
Even though China's halfway.
$15,
around the
you can probably find one in the U.S.
Some people do this.
I bought mine off of eBay, and I think I only paid like $1.90 for it. I mean,
Okay.
they're pretty cheap. I just happened to use AliExpress because I was already on their site.
And how long does it take you to get?
I mean, I bought mine probably 6 years ago, and
Oh,
I don't know. I mean, it came from China, so I'm sure it was at least 3 weeks. You know, you buy stuff from China. This is how it works. You buy a bunch of stuff from China, and as it starts to show up, you go, "Oh yeah, I remember. I bought that. Oh yeah, I remember. I don't remember what the project was, but I remember buying that."
Give it a little
Sometimes-
bit. Pretty soon it'll be
Or
a
the
thing.
opposite side, if your wife
hell did I
says,
buy that for?
what's that?
Yeah, your wife says, what's that?
What's that?
another decade or two, right?
Yeah.
There have been a couple of them show up that I've gone, "What project was this for?"
This will just go in the inventory.
Oh, well, I'll tell you another good one. I bought 10. It was sold in groups of 10 voltage dividers, so that you could basically a couple of resistors, you know, and
Yeah.
10 of them for $1. It was like, okay, it's good. So I bought some. 4 days later, I bought 10 more. 4 days after that, I bought 10 more because I figured, you know, I forgot that I had bought the first ones. So I've got 30 or 40 voltage, these stupid voltage dividers. If anybody ever needs one,
I try to remember to, every time I get the receipt in the email, I put it in one directory, and when I get the thing, I find the email and, yeah.
I started keeping a list of stuff I bought on Todoist.
Mm-hmm.
So the problem is I don't always remember to copy it from the eBay listing or the AliExpress listing and put it in the to-do list.
All right, well, let's get started. Introduce yourself and your, any topic you may have of interest.
Yeah, my name's Art Elsey. I'm visiting from California. And I have a running gun battle with a raccoon. I have found a solution. This is a battery-operated fence charger. It operates on two D-size cells. Supposedly it'll operate for a long period of time because it only gives a single shot of like a few microseconds every 1 second. So it's very low duty cycle. So it's almost the shelf life of the battery. But I have a running gun battle with a raccoon who seems to think that the feed that I put out for the birds is is his special territory. So I actually got a daytime shot of him a week ago or so. He was out there, not in the bright sun, but in the right before dark, cavorting around, and but he wasn't up on the post. He was just, so at any rate, per Jim's suggestion, get a fence charger. And the problem I have is that this bird feeder is like 75 feet from my house. So I didn't feel like stringing an extension cord in the grass and so forth and so on. But I found this one, and it operates on 2 D cells. So I will report next week how well it worked.
Quanto
Worry about
dinero.
kids and dogs?
Pardon?
Quanto
Don't worry
dinero.
about kids or dogs?
A dog will only pee on it once.
And the
Kids,
kids,
you don't
maybe
know.
3 or 4.
No. Here's the way it works. The shepherd's hook is iron or steel, one of the two. This sits up on the top of the shepherd's hook and connects to the bird feeder, which is insulated from the shepherd's hook. So I'm not worried about dogs.
He has to climb.
Pardon?
The raccoon has to climb.
The raccoon shitties up the shepherd's hook, and he's done a terrible job on this. I mean, I've fastened that bird feeder there real tight. He doesn't bother him in the least. I find him laying over in the yard someplace or another. Near as I can tell, he gets to the top of the shepherd's hook and does a Hail Mary with it. So we will see.
There's an alternative you might consider. Different species react to things differently. And as I understand it, birds do not react to hot peppers. They don't feel them, they don't taste them if they're hot.
Yeah.
So if you load your bird feeder up with ghost peppers, the birds are gonna be happy, but the raccoon,
It's gonna go in
Yeah,
hot and come out hot.
but if he doesn't like it after he's done the Hail Mary, it makes no difference to me. I
But
mean,
they're very intelligent.
but the
Yeah.
likelihood of them going after a tasty meal after.
yeah, that's true. So
Absolutely.
at any rate, this is my whole plan. I first bought one of these shields that is supposedly a squirrel shield.
Doesn't stop squirrels
It's
either.
it's about this
Oh,
big
it is,
around
man.
and shaped in a low angle cone, and that didn't bother him at all, man. He just went right around. I obviously this happens at night and I can't see what he's doing, but the squirrels seem to be somewhat deterred. So this is going to hopefully take care of both squirrels and raccoons. And basically the way it's set up, the birds can't get shocked by it because now if you had a buzzard, it could lean over, but buzzards generally aren't interested in bird seed. So we'll see.
They're interested in other prey.
That raccoon.
Right.
Right. And
Yeah.
had raccoons, yeah. So anyway,
Voles and mice.
yeah,
I'm Steve. Having grown up on a farm with a lot of electric fence, I can only offer you good luck. Raccoons are amazingly intelligent animals, and I would not be surprised if he figures out to disconnect the wires on that thing.
okay, well, see,
That's the same story I was thinking. Make sure your wire goes up, it's nice and tie wrapped all the way up, and the connection is up above where he gets shocked.
Actually, if I was doing that, I would get wire ties,
Being really,
the
really
kind that
slow.
have a long tab on the end with a hole through them.
yeah,
And I'd put those on your shepherd's hook and do a spiral of the wire through those. So it's
May have to
insulated from
rethink
the hook.
how it works.
well,
And
this thing's
put
gonna,
that above it.
this thing is gonna sit above,
Yeah.
sit on the top of Shepherd's.
Yeah, but I would electrify from, say, 3 feet to 5 feet up,
Okay,
so that as he's trying to climb, he's got to spend some time on that wire.
okay. I think this is it.
Yeah.
All else fails, you can put a trap out.
I'm Leroy.
I said, if all else fails, you can put a trap out. I mean, I've done that.
Steve,
Steve,
Steve doesn't,
You're done?
Steve done already said stuff. I said Leroy. I'm Leroy. I'm Leroy.
Vicente?
I'm Mike, I'm here to learn.
Somebody saw me.
And
Mike?
Mike over here.
Anything going on with you, Mike?
Mike's all in.
Still working on
I
some half-half
think it
projects,
froze out.
buildings and stuff. Nothing, nothing that is particularly
You're go-
close to this.
We're gonna have to rethink how
Okay.
it
Frank?
works.
Well, finish with my
That's not bad.
summer exercise with the kids.
Well, okay.
I'll be getting back to my sump pump, I'm into predictive sump pump now. That it runs pretty much like without the sensor and only has an alarm if things just get out of hand. And that's predictive is because you collect a certain amount of data, you know how long it runs. So, you know, like right now it runs like once every 53 minutes.
That's work.
And that works well, really well in dry weather.
Yeah.
It also works pretty well in wet. But sometimes in wet, I have this sensor at the top that says it gets out of hand. It's more often.
Adaptive control.
Yeah. Not to check. Of course, it hasn't flooded, so.
Okay.
Phil, and I'm not really working on anything, but I'm interested in the raccoon results.
Okay.
Okay, well, I've only got one more week, so I'm gonna get all my data next week. After that, I'm back to California.
That's good.
Up on the screen right now, that's the little camera. It's really the only way I know how to show it. So you see his hand.
Okay.
It's the only.
Like
That's the
five-
easiest way I know how to show it.
per second.
At least right now, because it doesn't appear like the website's actually working. There's Jim. Oh, Jim's on the little teeny tiny screen.
Okay, cool. 480 by 640?
Excuse me.
640 by 480 resolution. for the
Uh,
camera.
You've got it smaller, a lot smaller.
160 by 120.
Oh, really?
Set the
This is the screen, right? But the camera can reach VGA like 6080.
Yeah, 640 by 480.
680 by
640 by 480.
yeah, exactly.
Yeah, VGA. So that's really cool.
James.
Okay, introduce yourself, James.
I'm James.
You got anything
No.
to talk about? I'm Jim. I get my turn, right? And now
You're the head guy.
I've been flying the quadcopter this week. I got a new battery in this week. Haven't tried it yet, and good results. Flew it long way out back, and lost sight of it. Couldn't hear it anymore. Couldn't see it. Pressed the home button. Walked down to the field and plotted a way to get to it in case it didn't come back, and walked back up the hill, and it had already landed. Thank you very much. Long distance, I'm surprised. It's like quarter miles.
What frequency is this working on?
It's 2.4, I think.
Oh, so it's standard Wi-Fi,
Yeah.
802.11?
Yep, it's Wi-Fi.
Hmm.
Long distance line sight. Okay. I don't see the
I didn't see it either.
Chromecast. Okay. We'll just skip it. Let's see if there's anything I want to talk about in there. Oh, yeah. Okay, what do we want to do? We're going to do Vicente talk about his thing first, or we already done that? Or?
Well,
I can't wait. It has several stuff there to show.
Oh, you want to wait till the end? Okay. Frank's got something for us too. So you want to do him first, or
I need to connect us to the,
he wants to do a video?
well, right now our Chromecaster thingy isn't really working right.
But you're ready with HDMI?
yeah, you can put in.
Okay.
I guess we can do that. Except I can't record.
Okay.
Is this long enough?
It is if two people hold it up over their head.
Is there another connection down there?
There's one on the other side.
One on the other side of the room or one on the other side of the room?
Side, yeah. We want to do that? Hang on, Frank, we'll move
Come
it over.
here. Frank,
We'll move it over to the other.
Frank, come here.
We have to have somebody that can see over there.
You wanna move over?
That seems to be a
Wanna
technicality.
move over here to Vicente seat? Okay.
It lies.
I'll move.
Probably
The
right.
head is incorrect.
Receive the block, transmit the block.
When it's my turn, I'll say what I thought it was.
Sir, musical chairs.
Oh wow, look at all the icons.
What's that? We're putting in the house.
Here's your moves.
Okay, now I got too much stuff there. Okay,
It got a busy desktop.
and I'll tell you what else. It's actually worse. Oh, no. It's Microsoft now.
No wonder. I should get the Apple bigot to say that though. I hate everyone, so it's
I restarted it just.
Who's the Apple bigot?
I don't know. We're looking for one, desperately
Yeah.
seeking. If you know an Apple bigot, we need one. For sure one. It's hard to keep a good Apple bigot.
Okay, where it is. This is it. Okay, let me tell you what this is going to be. Y'all know I do this computer camp. And this is one of the kids who has graduated and he's doing a technical paper. He did a technical paper at a conference. And for me, this is special because I knew him when he was 8th grade. And he didn't talk at all. I mean, he's very smart, but he didn't talk.
Oh, this is that guy.
Yeah.
Oh, okay.
Not of them, actually. But now he sounds like a professor.
Just shy.
I remember being in Cincinnati. Princeton University. And the topic of my IT showcase paper is the applications of computational network analysis and advancing drug discovery. Now let's begin by addressing the obvious. What is drug discovery? Drug discovery is the first step in drug development, a five-step process as outlined by the Food and Drug Administration, which scientists can identify and test drugs for test compounds in the hopes of developing new drugs, testing, and clinical trials on patients for last reaching FDA review and hopefully getting approved at least one drug from this process. As you imagine, this involves a lot of computational analysis, a lot of scientific analysis, but as you can see in figure 1, it requires a lot of time. Shown here, this process of drug discovery, preclinical testing alone can take in excess of 6 years, or the whole process can take in excess of 10 years. And that's not all. The process also levies high costs on the researchers that perform it. The cost of developing a prescription drug market is estimated by Tufts was about $2.6 billion. Worse still, the trial success rate is rather low, with clinical trial success rate being rated at below 12% and having a low return on investment for investors. And simply, the process doesn't really have these sort of gains that you would expect, considering the high cost that would be paid. So what can we do? Well, it's a process that involves a lot of data, and involves the analysis of how those sets interrelate. And as such, we can look to data science for a solution. And one of these solutions comes in the form of networks. And the networks are a subtype of point connection models called graphs. Now, graphs are a staple of discrete mathematics. They're introduced by Leonard Euler in the early 18th century to address the bridges of Königsberg problem, which is essentially that's can you reach each spot in the city by crossing each bridge only once? A complex problem, although seemingly simple, and as such, the mathematician developed a method of simplifying it even further down to these points being nodes and these paths being edges. Now, a ball and stick model doesn't seem too complex. It's getting power just from the computational statistical methods that now accompany them. We look at Getty and Scientific, two popular options, and both of which contain these features that allow us to see the relationships between points. From simple edge-based weighting, which you can see how many edges run into it versus separatable or separable these groups are depending on the amount of edges within a cluster versus outside of it, and clustering coefficients which focus on the nearness of points relative to the others. These have many applications in many other aspects of biology, protein-to-protein interaction networks, systems biology, but what we can look at here is the interactions in biomedical and bioinformatics specifically. So looking back to the issue of these high costs of drug discovery, what we see here is a problem no longer in natural science or data science, and as such we have really two big paths that we can look at. There's an issue with the algorithm. You can either adapt the algorithm or change the algorithm that we're using. And from this, you can look at two promising solutions. The first is advancing network analysis itself. And what this amounts to is upgrading the algorithm to employ more complex methodology. And then the other method is drug repurposing, which looks at rather than developing new drugs, we'd be taking old drugs and comparing them to diseases in new ways to try to find new connections. And it states here the advanced network analysis method is favored by many players in the commercial space, whereas the drug repurposing method could be shown more easily, I believe, in the academic space with the innovations of research. So when we look at advancing frontiers of this is with deep learning. Deep learning represents advancement in machine learning technology. And rather than feeding data in and allowing the machine to train itself and that being it, deep learning focuses on reinforcement. So results is not feasible within the field, we get a negative reinforcement, and if it is feasible, we can point to future discoveries and get a positive reinforcement. And what happens then is that the machine can train itself to find new results and essentially learn from its mistakes. Now, where can we apply this? Well, there's been a lot of progress in this space, a lot of fun commercial players. Johnson & Johnson and Benevolent AI working on novel clinical stage drug candidates, working together on that through all their subsidiaries. With Google's DeepMind, a subsidiary that works specifically on deep learning, pushing the focus now towards protein folding and all the applications of that in environmental informatics. And AstraZeneca, another big name, looking at working on recurrent neural networks with, there's that buzzword, reinforcement with purpose. Although they show promise in reducing costs by speeding up the analysis and showing providing more insights, there's still that issue of new analysis. Now, drug repurposing allows us to use old drugs and analyze them for new connections. Now, the research of scientists at the Division of Biomedical Informatics at Cincinnati Children's Hospital Medical Center really elucidates these by really pointing out two intuitively derived factors that have to be in play for drug repurposing to occur. The first being distinctly separate groups of diseases and distinctly connected drugs, because otherwise you end up with what's called a hairball network, where everything's connected to everything else and you can't really get meaningful results out of that. Now, these are demonstrated through two papers of theirs that have been published fairly recently within the last 10 years. Now, the work of disease networks focuses on the benefits of a multi-factor analysis of rare diseases. And what really the impact of this is that because these diseases don't have a lot of data behind them, the researchers were pushed to analyze all of them and analyzing them through specific factors. And what they were able to find was that there were factors that you could not, or insights that you could not tell unless you used this form of analysis. And one of the consequences indirectly is that you can see that specific factor-linked modules can exist in some of these disease networks. These diseases, even rare diseases, can be split into meaningful groups by their categories. And from that, we can also look to whether these drugs can connect to these groups. And our second paper, computational drug repositioning through heterogeneous network clustering, and they focus on specifically on the ability to retarget drugs at a larger scale. So what they're able to find is that using this rich method of comparing comparing nodes of diseases and drugs by all these factors, that they were able to identify new indications of patterns and really see things that you could not see without this new form of analysis. And one of the implications for drug discovery here is that you can connect drugs to specific groups of diseases, and that these connections are non-trivial, non-promiscuous, so that they aren't to everything, and that you can separate these with these, as I mentioned earlier, network softwares to look specifically at how these drugs connect and by what factors that they connect. Now, really, what's the results of this? The result is that by targeting old drugs to new diseases, we can see the possibility of substantial reductions in costs, because the trials you would have to go through many of the earlier stages of testing, specifically from FDA review for safety. These drugs have already been tested on humans and shown to be safe for their use. And although it's hard to find some aggregate numbers on how these costs have been lowered, anecdotally, some have reported substantially lower costs, in some cases of upwards of 80%. So, where can we go from here, having seen these two approaches? Well, it's obvious that both of these shows that promise will continue to be studied. So one of the things we can look at is the surrounding factors, like some of the things that are limiting these technologies, namely a lack of computational power and a lack of available data. Well, computational power, as we know, just from the last few decades, has only been on the uprise, and further, there are some companies companies that are even specifically tailoring architecture toward these complex analyses called tensor microarchitecture, which is optimized for deep learning analysis. And further, as these systems develop data, they produce these new insights that specifically or particularly for deep learning networks, they can use to build these new connections and new insights. So as both of these things increase the processing power for the training data, networks for both novel drug development and repurposed drug development can increase in complexity and produce more nuanced, specific results in the future. Information technology has really enabled this new frontier in biomedical science with the visualization and high throughput analysis for some of these software, allowing us to more easily observe these connections, and with techniques like deep machine learning and clustering analysis, global analysis, allowing us to better quantify and place empirical numbers on how these diseases and drugs and frankly human genes are related to each other. And of course, drug discovery is one of these resources.
This is one of the kids that you met when you were at camp. I should also say he was in a technical paper, and he's 19.
It's an amazing subject.
Huh?
It's an amazing subject.
Yeah. It actually it should have been more time, but that's the amount of time to give it, because you start talking about the graph theory and the edges and stuff like that, and you just went on through it. Or it's a paper that you give to somebody who's already kind of in tune with what you're doing. But for me, I just like to hear him talk.
Okay. I thought he looked familiar. I thought I
Yeah.
recognized him.
Yeah. There's another group of kids that compete in a programming competition, web competition, and we got third place this year out of 13 teams, which is better than we've done in a while. They had to program in 8 hours an application that a lawn care service would use to map out their routes. And they had an algorithm for doing it, and they also had like a 300-page written test that they had to complete. So combination of scores will give you the score. Didn't have as much prize money this year. Like they got $500 per kid. Usually third place will get you $3,000, but it's a good experience, and they learn a lot. And generally, when these kids go to college and they go into IT, mechanical engineering, whatever, they're just ready to go. Because a lot of them, like he has been around, for 5 years. He's a sophomore in college now, but most of them stay around for 3 years. So they go through that same process of trying to learn how to develop web applications. Not just do it, but do it in 7 hours, which is not enough time. It's also fun for the instructors, and it's much more fun when you see them grow up. And it's like seeing the kids grow up. My God, where'd they come from? And especially in 8th grade with introverts, these kids are extreme introverts, And, by the time they get 18, they learn how to talk, and it's amazing. There's another little on my YouTube page of the other team, but I wanted to share that with you guys.
All right, thanks, Frank.
Very cool. Can I have my HDMI cable back?
This is working, the camera.
Okay.
Got very colorful.
Yep.
What happened to?
That's with his $2 camera.
Oh, that's neat. How did that happen? It froze up again, didn't
It's
it?
corrupted.
It was giving good pictures until you wanted to show it off.
Yeah.
Story of our lives.
I think that the antenna is covered by cables all around, The antenna of the ESP has the breadboard under and all the cables over.
You need to market this.
Yeah. How to adapt the breadboard to the ESP32. I
You
just
put that
got-
how-to article up on Google Plus, the club site. He's basically cut the breadboard in two and
Yes.
separated it, and it's now you can adapt it to any width, plug in on.
You can use it with any.
Anything.
Anything with that pin separation.
Can I have the HDMI cable?
Now there is an Australian Arduino that is inside the breadboard. All the Arduino is inside the breadboard with the pins.
I'm probably gonna need to. We're probably gonna need to plug it back over there.
It's too slow.
Yeah, something happened because it was working. I saw it.
Yep.
It was working. I saw it.
It's the library.
It's the library. Are we ready for me to do something?
Yep, yep.
Or not do something or whatever. All right. So I started off with this project, which is a International Space Station tracker
Laser cannon?
and laser cannon. No laser cannon.
Knock it out of the sky.
It's really hard to see it. It's going to be really hard to see it, and if we do it upside down, that's going to make it worse. Let's drag this over here. Gotta find the right focus. So anyway, the original project, I probably did this 6-8 months ago. It's using a service called Open Notify, which has 3 APIs. One of the APIs tells you the position of the ISS in latitude and longitude. One of the APIs tells you how many people are in space, and one of the APIs gives you past predictions of where, based on your latitude and longitude, where and
How
what
far?
time
How far?
the ISS will be near you. So you can see this is just a real simple. I'm displaying all 3 pieces of information on this display. Now, there's some math going on, and you really can't see it here, but it will tell you how far away the ISS actually is, approximately. And it's pretty good, but it will also start to alert you when it comes a little closer to you, so that, like the ham radio in me wants to run out and make a contact with the ISS. I need to know that it's pretty darn close. So, but that's where this project started from. There's a API called Open Notify, and this is on an ESP8266.
Is this on the web?
Mm-hmm.
Okay.
Somewhere.
So
This one's actually a very old project.
it's some kind of web service subscribing.
Oh yeah, it's not really a subscription. It's just a web call that you're making. Depends on which API you want to use, but basically you send it your latitude and longitude, and it sends you back where it is. Yeah. The people in space doesn't need anything. You just say, hey, tell me the people in space, and it sends back a JSON string. So could just use.
Who takes care of that? Who's the volunteer?
Somebody named Nathaniel something or other.
Nathaniel has Netflix or keeping the data for the
Yeah, well, there's
maybe there is a formula, just
there's several.
periodic stuff.
What he's doing is he's screen scraping NASA to get the information. But there's several other ISS places now. The reason why I used his was because he didn't require an API key or it's there's no security. It's just an HTTP call. So you don't need to do any weird proxy stuff or anything to get it. You can just get it. There's actually a better service. I forget what it's called, but there's a better service that gives you a whole lot more information, like how fast it's actually moving and if its trajectory has changed in the last 24 hours, where they say it's going to be, and all kinds of other stuff. But they require all kinds of other stuff to make it work too. So
Doesn't it travel roughly about 17,000 miles an hour?
it's like 27,000.
27.
Yeah. But that it changes. It depends on what they're doing. So anyway, there's other services that do it. Somebody in Italy saw that project and took it and improved upon it to a great degree for this little device called an M5 stack. The M5 stack is an ESP32. It's got the screen in it, obviously. I've got a battery pack for it. It's got just a ton of stuff. There's a compass and a IMU sensor in it, and there's just a ton of stuff in this thing. So I bought this because of what he did with some of my code. I wanted to see his code. So I took his code and modified it yet again for a little bit because I really liked what he had done, but it wasn't quite right. I bet it works fine in Italy, but it wasn't quite right here. So I modified it again, but I can't show you that because I dropped a laptop on this and busticated the screen. But
Figured out the packaging to get all that stuff in there.
I did because I am smart.
Did you do that? Did you create the package?
This is before I dropped the laptop. See, it's not the greatest video in the world, but at least I have it. So the code that he had didn't have the distance on top or the time on top. I added that in to him. He also, every time it refreshed the map, it would actually clear the screen and draw the map. I stopped it from clearing the screen because it actually is a smoother animation without clearing the screen. And when the ISS actually was in view, it actually looked like the ISS was moving. He had past predictions, but only in local time. I added UTC time as well, and then I added the people in space.
That 4,408 miles, is that how high it is?
No, that's how far away it is. If you were
Straight line?
yeah,
Forget
it's based on the latitude and longitude, so it would be a straight line. It doesn't take the altitude into consideration.
How does it get its current?
The ISS is correct. Okay. So that was one of the big changes. One of the other big changes I did was it's freaking hard out. So when it says stop. So where it gives the latitude and longitude and the GMT offset, I actually found it's called. God, I'd have to look at the code. There's an API that
But it's based on your IP address.
it's based on the external IP address of your network, of your router, and it's pretty darn close. That's actually within about a half a mile of where I'm actually at. So it's actually pretty darn close. So I grabbed my latitude and longitude from that API, and then I use timezonedatabase.com to grab the GMT offset and to set the current time in it. And if I go and I change the modes again, it will go ahead and update the current time from time zone database. So the time zones, it'll keep the current time, but every time you change modes, it will actually go and update the time just in case something weird's going on. But yeah, those were kind of my big changes to it. Was he was using Google Maps to get the GMT offset and the latitude and longitude, and it just was not working for me at all. And this actually seemed like it's working. What he was using had me about 150 miles away from where I was, which, that's pretty darn far. I can live with a a mile away, and it being okay.
Yeah.
But
What's the GMT offset again?
so GMT is Greenwich Mean Time or UTC time. That's where time starts. It's 00.
Over in England.
So you need to know how many seconds to subtract off of it or add to it, depending upon where you are in the world. So that's the number of seconds. We're 14,400 seconds. And time zone dv.com will also give you it gives you the time zone you're in, and it will give you if you're in daylight savings time or not. So it will actually adjust that number.
The GMT and the universal time, they're
same thing, pretty much the same thing.
Now,
actually,
I keep hearing because of global commerce and everything, that's going to be the business standard for time.
What, GMT?
Yeah.
It's UTC is the standard. Nobody says GMT anymore. Everybody says UTC. And if you look on like Wikipedia or something, it'll tell you that the two times are actually different, but they start at the same spot. So go figure.
Over at Greenwich.
Yeah.
England.
Yeah. So that was a project that I really wanted to do. That was the project that I thought, this is really cool. And then I smashed it.
We now know that Case is not laptop proof.
Basically, don't throw a laptop on top of your toys, and everybody will be happy. So I quickly, and I'm talking quickly, so don't like freak out if I don't know anything. Threw together a few more mesh network things. So what I have is a D1 Mini, which ESP8266 based, with 7 WS2812 LEDs on them. I've got 4 of those, and when you plug one in, it will light up, and yeah, it should start doing some animation and whatever. We don't want to blind people.
For 2 hours stream, that's pretty.
So why isn't it doing anything? Please do something, because you should be doing something. There we go. Okay, so this is just going to kind of cycle through. What's going to happen when I plug another one in, they will negotiate with each other, and then they will actually
Sync up
become in sync.
and then sync.
Well, sort of. The code that the guy that did this code, he has maybe I could find his video. He has these as LED strips, and he has them up on his wall in like an array, and I think there's 7 of them, and they actually will go off in sequence. So they know which one was plugged in at what time, and they will go boom, 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 boom. So it goes red, green, red, green, red, green, red, green. But we'll try it, and we'll see. So we can see there we've got green and blue, and they should. There's the sequence. So they should sequence up. Now if we here, I might let you.
Be careful with the short circuit.
I'll let you pull up. Oh,
You ready for me to plug it in?
whenever you're ready. It'll take it. It should only take it a second or so to.
Cables. Funky.
So it's out of sequence. It's out of sequence. It's out of sequence. And it's being bad. Come on. There we go.
Okay.
We've got
Green, green, green.
It's like you're talking that they are changing
so
message. This is the red is a message.
Okay, now it's something's up. Are they talking to
Now they're all
each
green.
other directly, or are they all connected to
well
the library Wi-Fi?
no, they're talking to each other directly. And once they all sequence up, it takes them a couple of seconds to actually sequence. But once they start to sequence up, it doesn't matter which one. Like that was the first one I plugged in.
Now it's
And
renegotiating.
It renegotiated quickly and started sequencing. So you could unplug any of them. It's a self-healing mesh network. It just takes a couple seconds to realize that, hey, something actually did change.
This is using Espressiv's mesh.
No, that's using painless mesh.
Oh, okay.
This is not a standard Windows D1. It has something special, the theme, or
No, it's
the
a
same,
standard.
the same one
It's the same one.
to be used
Yeah.
with another software.
So these are transmit, repeat, receive, repeat to the next one, and they'll extend the distance. As long as they're kept a meter apart, you can extend them to 100 feet.
Painless mesh can be used to send a message to one or to all. It's actually sending the message to all of them, but it doesn't care if it disappears or not. So the sequence could be the sequence could get pretty long. I think they said the upper limit was something like 256
Okay,
devices.
what about the distance?
It doesn't matter as long as one of them can talk, all of them are going to talk.
But does it repeat? Let's say I have one here and I string them across the library to the other side. Will they feed all the way out? Okay, they'll repeat.
Is it the ESP now?
No, it's not
It's
ESPN now.
very like that.
This is ESP now, which I still haven't gotten to work right. Uses, yeah, I guess it is sort of like ESP
They
now.
relay the messages,
Yeah,
but then you have a intermediate node
yeah,
and final transducer node or something. They have personality.
yeah.
They cannot change their function like this one. They can be anywhere, just repeating everything.
Painless mesh just seemed like it was painless to set up. You just install
What's it?
the library and it works. It just sort of works. Couple weeks ago, when I was showing off some of this stuff for Steve, the day after that meeting, I went home and I found these stupid little modules called ESP Mesh. ESP Mesh lies. It lies.
It's a marketing thing.
It's a big fat lying thing. It's using the ESP-M chip, which is, I don't remember what that number is. It's an 82, no, it's an 85, 80.
The one that is include the flash inside
Yeah.
the chip.
Yeah. Let's see if I can find it in my list of things I've bought.
Something 85. 86, 85 or something like that.
I thought it was 85, 80.
85, 80.
There's an 8285.
82, 85,
yeah.
that's the one. I like when we were talking, I was saying I was hoping that there would just have like a mesh stack on it instead of the Wi-Fi. They work exactly the same as the other chips. They just have less memory and they this is the one I bought. I bought 4 of them. So there's actually not a whole lot of information about these on any website anywhere. One of them I bought, I think it's the blue LED, doesn't work, but it's got an RGB LED in it. And if we plug them in, it would pretty much do the same thing. I'm using a different piece of software to actually do it, but it would pretty much do the same thing. You could actually see it because it will start to flash how many of them are actually connected. It'll flash the number that's connected. So we could give that a try. And it renegotiates a little bit better too because, or a little bit differently because so there's a blue LED flashing there that it's just flashing one time. Basically saying there's only one thing connected. This one,
You have the same software each one? Or
No.
a different number?
No, oh yes. There's no different number. It's based on the MAC address.
Identified by inside.
Yeah. There's no different number. It's just based off the MAC address.
Address of the chip.
So that one should, when they start talking to each other, this will start flashing twice and this one will start flashing twice. And it hasn't done it yet.
Oh, is it its own? Oh.
That black connector is kind of
Is this
finicky.
Let's try a different power cord then. Green. It should be flashing. There, I just saw it do it. There's 2 of them.
Yep. So which mesh software is this one using?
I think I'm still using Painless Mesh, but I'm doing it in a different way.
Oh, okay.
Now this one, when it comes up, it should blink just one time, and then once it negotiates itself, they should blink 3 times, because there's 3 of them on the network, and it should be doing it because that one's blinking 3 times. So if you unplugged that one, which was the first one I plugged in,
Yeah.
it'll renegotiate itself and say, it'll take it just a half a second or so, and it should be blinking twice.
3 times.
Let it figure it
They
out.
are counting how many of them are in the network, right?
Yeah, that's what it's doing.
I think
There it
it's
is.
doing it too. Yeah.
When it's negotiating, each one of them sends its IP address, or not its IP address, its MAC address, and each one of them make a list of the MAC addresses. And then once they know the MAC addresses, they start looking for those MAC addresses. So it takes it a couple of seconds for it to realize, no, that one of them's not saying. It also sends a time pulse and a sync pulse and something else, which is what this is supposed to show is the timing of it. When it flashes the light, it's saying I'm sending a timing pulse. So we can plug this network and this network are 2 entirely different networks. They ID themselves differently. They're basically accomplishing the same thing, flashing lights, but they work differently.
So are you in this library?
Yes.
Do you have to query for which one is master at the moment?
No.
Or is that all handled inside the library?
The painless mesh, it is a self-healing mesh. So if the master goes away, it will just say, I'm master now, or
Okay.
one of these will decide that it's master, and it just sort of handles it. I disabled it. If we had started with the serial console, one of these demos, I've actually got it where it shows how it negotiates which one's master and which one's. And basically, that one probably would have been master because it was plugged in first. But as soon as we unplugged it, it took it a couple seconds, but it realized that it needed to renegotiate that. These mesh networks are very, very cool, but this lies. It's not they stuck mesh on there just to fool me and make me buy it. But it was $2.60. So it's using Wi-Fi. It's not using anything else. I was hoping for like I said, an actual mesh stack on top of it, not something that I was hoping for something that I could just use just out the door. But no, that's not what it is. These came with the AT firmware already burned on them, and of course I said no, got to do something actually useful. So, that's it. That was my very, very quick last minute because the core blew up thing.
Somebody else this week was squawking about they're gonna obsolete GPS is obsolete. There's a company that's has hardware that's going to obsolete GPS, and you guys heard anything like that?
Obsolete GPS, huh?
I don't know, there's a company, so I'm a little suspicious of them. They had a little piece
It's a
of
bold
hardware they were hyping. Let's see if I can find it. Start with D. Anything have any? Anybody have anything?
I did see, I mean, because you can get pretty decent. It's not great, but you can get pretty decent off the IP address and the MAC addresses of routers that are around you. You can get pretty decent location.
Yeah, they were saying that based on the ones you could get, something like that, and you could interpolate where you were based on the hardware that you could see.
That's more or less how I'm getting the latitude and longitude on that thing. It's just based off of the IP address, and it's pretty good.
I have here something to talk about. This is the project about to have a sensor in the front door that the dog can touch to tell open the door in winter or when it's raining or something, or every time he wants to come in, he just touch the down, you know. This is in the knob of the door. This is a vibration sensor.
Oh, okay.
The idea is that this circuit will be of the size of the bell, will be with a bottom battery, will be very tiny, but this is the concept right now, right? Each time the dog touch, it sends a message to another device that is in the kitchen.
My mailbox sensor is dead again.
This is
I'm looking for
If that's what's inside the kitchen.
this one will be a like a box with different buttons, like the buttons with light, you know, and you know which button was activated, front door, back door, or you can use garage door alarm or the mailbox alarm or anything with the same concept. You can put this in the door of the mailbox, and each time you open or close, it will send the.
Are you using the 433 megahertz receiver?
Yes.
Okay, the cheap one.
This is the receiver.
Okay.
Okay.
Not the Nerf, but the super cheap one.
There is a circuit that consumes zero current. You know, when you touch this,
Cool.
it turns on the MOSFET that power the device.
Okay.
And after he send the code and the information, it kills him itself and turn off again.
Mm-hmm.
And then you know there is no power consumption, no. And you send each time you send the message, you send the voltage also. You can check if the voltage is under some level, just to change the battery. But I guess this battery will last for 4 or 5 years.
That's what I need.
You can see this is Troy, and you put the Troy is the name of the dog, right? F is the let me change this because this turn off automatically.
Do you want this one? Here.
He's got one.
This one when you have low power, it turns off.
Can we do 100 feet?
500 feet.
500 feet?
I tested, yes.
Wow.
500
Okay.
feet is the range.
I'm ready.
Because I am using 9 volts in the transmitter. It's high voltage. Each time you move this, you send the voltage. The voltage of the battery is.
Oh, that's getting you the voltage. Wow.
Put that on Mimi's thing.
There is another
See if she's still alive.
There is another device that can detect which button was hit or was pressed and send a different message for each button. Oh, cool. And it turns off automatically also.
We need schematics and information, and we need the whole works on this.
Yeah. Does the dog
I
like
can
it?
see metal
Does he
lights
use it?
flashing in his head right now. Like, it's a eureka moment.
Is it windproof?
No, put the
Is that,
wind sensor.
Is that one of
So you can do anything with this.
How are you going to teach
data.
the dog to use it? Are you gonna hook it up to like a food
So,
dispenser?
so do you have a
How are
description?
you going to teach the dog to tap it?
He already knows. When he was 3 months old, he already learned how to ask to go out to make pee or something.
He's a pretty smart
So
dog.
was trained in science. We bought it.
You put some of this on Google Plus, the trigger
This
trigger
thing is,
things on
he
Google
knows
Plus.
the knobs of the house to go out,
Mhm.
back, front, garage. It goes and touch, and you know he wants to go out.
That's hilarious.
Actually, we can take a picture of this.
My
That's
dog
it.
growls.
Is that one of the super nanos, or is that just a regular nano?
No, this is a nano.
Just a regular
But
nano?
this nano was programmed using the SPI programmer because the bootloader spent 3 seconds after turn on waiting for the Arduino IDE to send the. And,
Oh,
and
yeah,
I need that in 50 microseconds, milliseconds, just to act. There is no bootloader in this nano. It's removed.
Is that golden retriever we saw?
Oh, yes.
Pretty golden
And you
retriever.
can use it, this thing close to the food or anywhere, and he just use the
They're
nose
pretty
Oh,
smart
we can't
dogs.
see that one.
to activate.
Does that work for children too, as well as dogs?
If you could train your kids to do it, if they're
You
smart.
can use this for water detect in the basement, for the mailbox. When anyone hits the mailbox, open close the mailbox.
So
The
if somebody
garage
runs
door.
over your mailbox.
I was planning to use this in the garage door with a level sensor.
Mhm.
The garage door start to move and turn on the device. You wait for 30 seconds, for example, and check the level. And you know if you are stick to the door, you know if you are vertical or are horizontal, and you report the position of the door in your central panel, wherever you want.
What's this sensor? Is that a piezo or something?
Mhm.
The sensor here, what's that? Is that a piezo element or something?
No, this is like a
Mercury?
spring. It's
Oh, okay.
mechanical.
Okay.
And very cheap. You know, it's like a tiny can with a straight wire and a spring around. There are different grades, very sensitive or very robust. And this is the most sensitive one. You know.
So that, they just changed the stiffness of the fiber inside?
No, the caliber or the spring, the sides of the wire, you know.
So a larger diameter spring would be
Yes,
less
yes.
sensitive.
Yes.
What about wind?
Well, the
Keep
dog
it
has,
out of the wind.
the dog has to do that outside.
You need to check
Okay, all we need is the parts list, the code, and a wiring diagram, and we'll be good. That's all we need. Put it on Google Plus, would be great.
the interesting part is this array of transistors. When you hit any button, you have a capacitor that turns on everything for 100 milliseconds.
Cool.
In this time, in 100 milliseconds, you need to read the analog channel to know which divider of resistors you are pressing, And then after that, you turn the microcontroller turns on by itself the write, you know. And after send the message, it turns off by itself again.
Okay.
But this is the idea is.
So each push button is a different value resistor, is that
Yes,
frequency
it's a ladder of resistors with different.
and it sends a different tone or duration?
No, you send different voltage.
You're measuring the voltage.
Oh, okay, gotcha.
It's a divider.
Voltage
Yeah,
divider, got it. Cool.
This is in this case. In this case, I am reading the voltage of the system and reporting the voltage of the battery, and then turn off after sending the information.
That's excellent.
That spring sensor looks something like that.
Yes, yes.
Ah,
Yeah, zooming into.
okay.
So it just sort of vibrates and hits the side. And
They are very cheap in China, but I bought all of them in Amazon, you know. I bought 3 or 5 different kind of them for $5.10 or something,
It's a tiny cow.
and check which one is better
Sort of like
for
that.
each application.
That's right.
cool. So when the spring kind of vibrates back and forth, it hits the side of the,
But
the
the
can.
idea is,
Oh, some inner
I was planning to use the
Okay.
microcontroller, the Tiny 85,
Mm-hmm.
but now there are a new microcontroller from Microchip, from is the Atmel line of microcontrollers, but made by Microchip. There is a new line that is called One Series that are very cheap, you know, and very powerful. And for 30 cents, you
Okay,
have
so
everything.
for a bonehead, it's not gonna program like the Arduino. It's gonna be-
No, you need a different ID to program. But it's in C. It's the same thing.
It's in C.
So a bonehead like me might have trouble.
Well, you can use for this. You can use the AT Tiny 13. It's the cheapest one. It's a 1K memory. I compile the program and it fits inside it. But will be 40 cents or so. Microcontroller.
Sooner or later, whatever the new chip is, somebody will probably build a board.
I got
for
a
the
nano,
Arduino.
I can drop $1.50 for a nano knockoff, okay? So I can use program it in
No, but
the Arduino IDE.
remember, you need, for example, a dozen of sensors to put in different places of your house to do something. And in the main console, you decide what to show, a message, an alarm, whatever. This is out of, it's not IoT because it's not connected to internet, no security problems.
Yeah,
You say this is 433?
433
yeah.
megahertz.
433.
That's the cheap transmitters and
Oh,
receivers.
yeah. Well, so you're just sending a pulse code for each.
I designed the protocol, the signing on to reach maximum distance and confidence of the package, you know. And last experiment was for 450 feet of distance.
He's using.
Yeah.
That's not exactly the
No.
the one.
There is a super heterodyne.
Yeah, you're using a better.
Which receiver are you using? Are you using a super
So,
heterodyne?
yes, it's better. The super heterodyne is better
It's much
than
more
the other
sensitive,
one.
Yeah.
Better.
He's using the better receiver.
And
but
use high voltage in the transmitter. Instead of 3 volts or 5 volts, I am using 9 volts, and you reach huge distance with that. You know.
and
But
he's using 433.
It can
and not
work
350.
until 12 volts, so you can use.
But it's only on for 100 milliseconds.
But it's
So you
very
said
short.
the
It's
battery
very
is
series of full
very
battery's
short
gonna last
time.
5 years.
Pulse code.
He's just sending one at a time. Boom, blap.
You need to
Done.
send a signal,
Yeah.
and then you codify the information you want.
Yeah, you have a preamble and then
Yeah.
you have your code.
You said the battery will last 5 years.
And
No,
those are really,
I need to
cheap.
check how
Yeah,
much
I
energy
know, I'm
with
using this
each
one before.
sensing, you know. But remember, the mailbox will be once a day. The dog may be 10 times a day. The basement will be once a year. That I hope not none. Um,
This is on the basement window when somebody crawls in or what?
well, there are some sensors, water sensors
Oh, water
know,
sensors, okay.
that you put on the floor that they produce a very high tone. Beep,
Yeah.
an alarm. You can use this to detect the tone, or just use wires to control the MOSFET directly by yourself. When water comes, you turn on. But the water will maintain the connection, and you will lose all the power in case of
Mhm.
a flood or something.
So stupid thing, years and years ago, using a pair of points out of an old car, put an aspirin in it. When it starts to rain, the aspirin would melt
Yeah,
and the points would close.
that was. And then also being with a candle for fire detector, you know, when the candle melts,
Yeah.
both contacts go closer.
Yeah.
So
Use a little wax button.
Yeah. Well, next step is to make a PCB as small as possible. This is the best antenna is this one, but maybe I just make a line in the PCB. Some S shape or something to make it very, very tiny. I want to have a device almost of this size, put in the knob doors, forget them.
The antenna, you have to maintain the length of the conductor for the antenna.
Excuse me?
The antenna is a coil to make it shorter. It has to be a wire this long to get
Yeah,
to a
I
shorter
saw
wave.
different solutions for that.
Yeah.
Is that name your dog Troy?
Yeah.
Okay. So it knows that Troy is,
No, but the idea is to have a general message.
Yeah.
Sensor, sensor one, sensor two.
so you
Sensor
kind of tell which of your 9 or 10 sensors.
You remember I show an Arduino assembling messages with different words that said Troy at the front door, Troy at the back door. You can combine it in the station to hear what's the signal, the alarm or something.
Now, have you gone the next step and think of wiring a button to unlock the doggy door for him? So Troy tells you right at the front door wanting to get in, and you acknowledge that you unlocked the door for him?
Well, it can be another device with a button in the door. When you open the door, you push the button. It's a small box with the same secret inside, and it tells the panel that the alarm is
Wonder how well that
set.
works.
Yes, but I'm saying you don't want to automatically open the door for him.
No.
So if you consciously say,
That
Troy's at
antenna,
the front door.
Steve, that antenna looks like it's actually on the board.
The dog will be.
You're right there, he's got a hard door.
Yeah.
This is I bought several of those. They are pretty bad antennas. Very bad. They look nice. They are small, but the antennas are the worst of them.
Yeah, it looks pretty.
They try to imitate a spring
Yeah.
antenna, but it's not doesn't work. Well,
It's
I have
cheaper.
4 meters of range with this.
Yeah,
I interchange. I have all of them, all the brands, all the sizes, all the shapes. I try all of them.
well, that
There's one
answers
in
my
the spring.
question, because that's exactly, when I saw that, I said, I wonder how well that works.
No, I have them.
It doesn't work.
Doesn't work. I had the hope, I was hoping that this works nice because it's just a tiny circuit, flat, no soldering antenna.
It
That's
probably
it.
would work all right inside the house, but not anywhere else.
I just walk out for 4 meters or something and stop working.
Anybody have anything for next week?
Well, I'm
Any
sure
topics?
somebody could come up with something.
Somebody come up with something? Other than cameras?
I am working with
Security
the
cameras, everybody?
The
Huh?
garbage can
That's a threat.
robots.
Yeah.
Trash can robot. No, trash can.
Transport.
Trash can
Again,
transport?
trash can
Okay.
transport.
Is that your volunteer?
No.
Oh, okay.
That's yours.
Oh, yeah.